Ladies and gentlemen of the audience, appreciate your time today. Thank you for giving me this opportunity. I'm going to tell you a little bit about Acro Bridge and the bridge solutions that we provide. So let's go ahead and jump right in. A little bit about the company here. We are the world leader in design, engineer, and manufacture of prefabricated modular steel bridges. I like to say we're kind of three things all wrapped into one. We are a material supplier, a manufacturer, fabricator, and design engineer of the prefabricated modular steel bridges for use in both temporary and permanent applications within the steel bridge or bridge construction industry. You can see there the company was started in 1951, just a few short years after the end of World War II. And there's some method to that madness in that the Acro panel bridge, which is what we're going to spend the majority of our time talking today, is derived from the old World War II Bailey Bridge. So you can see the company was founded just a short years after the conclusion of that war. The idea being that if this technology can be used for military applications, why couldn't it be used for domestic and commercial purposes? Currently, we are a privately held company with just over 300 employees. We're headquartered in Parsippany, New Jersey, with manufacturing facilities both in Milton, Pennsylvania, and then across the pond over in the United Kingdom. We are a global company. We have Acro panel bridges currently on 6 out of 7 continents. Haven't quite made it to Antarctica yet, and I stress yet because, believe it or not, we have an order in-house to provide an Acro panel bridge on the continent of Antarctica. So shortly, we'll make it 7 out of 7. Here in the United States, we do have staging yards in 3 different locations, both on the East Coast and the West Coast, and one that we just opened last year close to the center of the country in Millington, Tennessee, which is suburban Memphis. Again, we provide both the Acro panel bridge and the Maybe panel bridge in terms of the brands that we represent. Again, I mentioned it's derived from the old World War II Bailey Bridge. And again, we've participated in projects 150 countries over the world. Okay, so some of the challenges that our customers face, whether that's an owner like a state DOT, a design engineer or structural engineer, and or a contractor, is aging infrastructure, certainly bridge closures and traffic disruption, obsolete infrastructure, the idea that bridge infrastructure has high maintenance and repairs costs, obviously the need to respond rapidly when the case of a natural disaster occurs, and then obviously when it comes to remote access, again, not only in the United States, but the world over. So the technology is all derived around the concept of accelerated bridge construction, or for simplicity's sake, ABC. We like to say we are in the ABC business before it was an acronym. You see some of the segments that we participate in. Permanent bridging in the United States, we're probably best known for temporary detour bridging. We're still heavily involved in the military aspect of things, not only the United States military, but also foreign militaries. Again, you can't be in the accelerated bridge construction business and not be in the emergency bridge business. And so we still get involved with emergency bridging and also development programs. That's primarily state DOTs. We'll bring them into one of our yards and train their state DOT employees on how to build these structures. Okay, so probably what I spend the majority of my time when it comes to talking with state DOTs or structural engineers or even contractors is this idea of accelerated bridge construction versus phased construction. Again, we've been doing this over 70 years, and in an association with the Short Span Steel Bridge Alliance, we've determined that through case studies that phased construction is typically about 30 to 40% more in terms of the overall project costs as compared to accelerated bridge construction. When we talk about accelerated bridge construction, as far as Acro Bridge is concerned, we're talking about putting in temporary detour bridging. Okay, again, the Acro panel bridge and all of our bridge solutions are 100% steel solutions. There are benefits to steel versus concrete, the majority of them being the ability to modify the solution a lot easier, and around the idea of speed in comparison to concrete. All right, so some of the features and benefits of the Acro panel bridge solution. Again, it's made from 100% domestic steel that is melted and manufactured in the United States. The solutions are customizable to the desired length, or what we call span, roadway width, and then strength insofar as live loading is concerned. They are precision engineered by an engineering department that we have in New Jersey. Everything is hot dipped galvanized from a corrosion protection standpoint. These solutions can be installed very, very rapidly with minimal labor and equipment. And we also provide on-site technicians, all of which are retired military personnel that spent their time in the United States military putting together these structures. Okay, with each Acro panel bridge, you get the quality assurance of knowing, once again, that the steel is 100% melted and manufactured in the United States of America. We are an AISC certified fabricator, ISO 9001 compliant, and also recognized by various steel bridge alliances. Okay, take you into the main components of the Acro panel bridge in terms of our latest series of bridging called our 700XS. It's made up of basically three components. They are the truss panel. This is where the strength of the bridge is determined. Okay, our floor beams or transoms, and then of course our deck units. So if you think about sort of a loading diagram, vehicle interacts with the deck units, takes that force down to the transoms or floor beams, and then out to your truss panels, which again is the strength of the bridge. Okay, some of the applications that we get in, I won't list them for time's sake, but again, probably domestically, we're probably best known for temporary detour bridging, but we can certainly provide movable bridges, aerial bridges for utilities. We get involved in pedestrian bridging and rail bridge applications. Again, still heavily involved in military applications as well. So let's kind of take you through some of our different solutions and various different projects that we've been involved in. Okay, temporary bridge that I was personally involved with over in southeastern Texas, as opposed to phase construction or detouring traffic out of the way. The idea is put in a temporary bridge, you give the contractor full access to the permanent structure to be replaced, which is shown there on the right. And again, one of the questions that I get a lot of the time is, hey, is there a amount of space that the bridge has to be separated from the permanent structure? And the answer is no. At Acro Bridge, we say if it fits, it'll work. And the idea that you're seeing here is we give the contractor full access to the permanent structure to be replaced while detouring the standard traffic, keeps the public out of harm's way, keeps the contractor out of harm's way. And with giving the contractor full access to that permanent structure, that should shorten the overall length of the project itself. Okay, another detour bridge here in New Jersey. This is a multi-span bridge. I would tell you 2/3 to 80% of the inquiries that we get are for a single span bridge, but there's no reason why we can't provide multi-span bridges. It's just the same concept over multiple spans. Okay, one might argue that the limitation to the Acro panel bridge is that you can't put a curve in the bridge itself. It has to be maintained both vertically and horizontally in a rectangular configuration. However, we can get pretty creative with these solutions. As you can see, we kind of impress a curve into the temporary bridge over multiple spans. Another bridge here, we also understand the idea that sometimes utilities need to be suspended across the bridge in addition to vehicular traffic. So we can, kind of typical to see here, but there's some 5-foot cantilevered items there that can transport various gas lines or whatever utilities are required. Okay, here's an interesting project where, once again, the example of if it fits, it'll work. You have to replace both the eastbound and westbound bridges. So you put in a temporary detour bridge, again, giving the contractor full access to the permanent structure to be replaced. Here again, in some cases where you need multiple lanes of traffic going in each direction, uh, currently our limit is 3 lanes of traffic, but oftentimes you need 4, so we can do adjacent acro panel bridges to get both directions of traffic covered. Okay. Permanent bridges, when it comes to the design of the acro panel bridges, there is absolutely no difference between a temporary bridge and a permanent bridge. As a matter of fact, we design all of our bridges, temporary or permanent, as if they're going to be permanent. So there is no difference in the actual design of the bridging. Here's a situation in over on Hawaii where 2 bridges were required. Again, all built around the concept of accelerated bridge construction to keep traffic moving. A situation down in southern Arizona where initially this acro panel bridge is going to serve the South 32 mine near Patagonia, Arizona. After the mine is completed with its operation, this is going to become a county bridge and be in place for at least 10 years, at which time the county will either move it to a different location, maintain it where it is, or perhaps sell it right back to Acro Bridge. Okay, we can do some stuff with the aesthetics. If you want a cambered look to one of your bridges, whether it's permanent or temporary, this is a permanent bridge installation. And here again, you can kind of see a 5-foot cantilevered footpath on each side. That's for pedestrian traffic in addition to the vehicular traffic. We do get involved, as I mentioned, with emergency projects. Here was one out in Cibola County, New Mexico. There's a little town just outside this bridge by the name of, the name escapes me, but there's about 30 to 40 citizens of it, of the small town, and heavy rains had destroyed the concrete culvert bridge, which was in place. And so the county contacted Acro Bridge and said, how quickly can you get a bridge design and bridge materials to the site? We accelerated design and delivery, had the design done in less than 48 hours with trucks on the road 48 hours after that. So we can respond very, very quickly when situations like this do occur. Okay, another emergency project, this one over in Pennsylvania. Again, quick installation, reopen the critical quarter in under 2 weeks. And so, again, we can move very, very quickly when needed. Interesting project here up in the Pacific Northwest. An 18-wheel truck had collapsed, had interacted or smashed into the superstructure of this bridge, collapsing this particular span of the bridge, and the repair work was sort of caught up in some red tape with the state DOT, and you can't see it here, but on the south side of this bridge was a major Costco warehouse. The Costco store manager contacted the state DOT and said, every day that this bridge is out, you're costing me approximately $1 million in revenue. And so within about 30 minutes of that phone call, Acro Bridge got a phone call saying, hey, how quickly can you get us design and bridge materials so that we can open this bridge back up to traffic? And you can see we were able to complete that in 15 days. Okay, emergency repair work down on the Gulf Coast as a result of hurricanes and natural weather events. Here's a situation down in Jefferson Parish, Louisiana, where Hurricane Ida had destroyed the community's only access route. So once again, we had to accelerate design and the shipment of materials down to the site so that the contractor could construct that bridge and allow traffic to flow as quickly as possible. Okay, we do also offer what we call movable bridges. This is an example of a side-by-side lift span bridges. We do provide the entire superstructure, and in this case, it would be all of the mechanical and moving and electrical parts. So all of that is handled by Acro Bridge. If your preference on a movable bridge is for a bascule bridge, we can provide that as an alternative. Here again, we'll provide all of the mechanical, electrical, and control systems, basically everything that's the bridge bearings on up. Again, that can be on a temporary basis or on a permanent application. Okay, one we just got finished pulling back out because it was done on a temporary basis. This is in Glen Island Park in just outside of New York City, a bascule bridge to allow water traffic to pass under the bridge, so to speak. Here's a pretty famous project that we got involved with a couple of years ago. This is the Las Vegas Formula One, where this was more for local traffic to get over the track, which of course ran through the city of Las Vegas. This allowed local traffic to get through the city and not disrupt the Formula One race. Okay, some of the other applications we do provide temporary and permanent bridges for railroad applications. You can see here in the state of Ohio, the CSX needed a temporary bridge. I believe this was as a result of a collapsed bridge, and so we were able to provide that solution for them, all designed around Cooper E80. Another one of our flagship projects we were involved in, this is of course at Ground Zero in Lower Manhattan. That's an acro panel bridge in a sort of a ramp configuration with 5-foot cantilevered footpath on one side, supported by acro towers there. You can kind of see them in the background there. And so just another application for an acro panel bridge. And in this case, on an emergency basis. We have provided aerial utility bridges. Here's one in Tucson, Arizona. This one was provided as an alternative to directional drilling, which would have been much more harmful on the environment and also, quite honestly, double the cost. In this particular case, Hunter Contracting came to us and said, hey, we'd like to use an aerial bridge to support 3 18-inch OD HDPE pipe that were taking raw sewage from one side of this wash over to the other. And again, much more or much less impactful, I should say, on the environment and about half the cost of directional drilling. We do have solutions for relatively short spans, and in that case, we have what we call our acro beam bridges. These are 6-foot wide units that are provided in 25, 35, and 45-foot span lengths. Easy construction because they come to you about 95% constructed. You simply take them off of the truck, land them right on the bearings which are sitting on your bridge abutments, put in attach the side mounted guardrail, and you're talking about bridge construction in a matter of 60 to 90 minutes as opposed to days or weeks. We can provide these solutions in all different kind of live loading requirements, whether that's HS20, HS25, or HL93. Okay, here's a fully installed acro beam bridge. This is these again 6-foot units, so side by side. They made a 12-foot roadway width and designed for HL93. And again, you see single day installation. We also do get involved in pedestrian bridges. Here's one up in Seattle, Washington. Obviously, because the loading is a lot less, we can get even longer lengths. Here's a single span at 270 feet with a width of a walkway width of 24 feet. Designed for 90 pounds per square foot. Pedestrian bridges used for trail bridges. This one in Buckley, Washington. Same concept here, just for pedestrian access as opposed to vehicular access. However, this was designed to HS15, and so it could accommodate small vehicles, things like golf carts, maintenance vehicles, things of that nature. And so kind of to sum up why acro, again, hopefully I've demonstrated this in the short time that we've been together. Very easily customizable solutions based on span length, roadway width, or walkway width in the case of a pedestrian bridge, different strengths, again, yeah, the whole concept of accelerated bridge construction, where you can install these bridges very, very quickly with minimal labor and equipment. And again, engineering support both from our engineering staff in Parsippany, New Jersey, to our on-site field service representatives in the field. And so it's a situation where it's not like we hand you a lump of steel and say, here, have fun building your bridge. We are involved all the way from conception to completion. That is my presentation. Unless, John, you want to hold questions till the end, I'm open for questions. And of course, this is my contact information.
Okay, thanks, Dan. Appreciate your presentation. That was a great overview of Acro and some of the great work you guys do. We'll go ahead and hold some questions till the end, but I will ask you, Dan, if you can see the Q&A panel, there is a lot of specific questions coming in on Acro and your capabilities. If you can click that and maybe answer some of these while our next presenter is presenting, that'd be great. If not, don't worry about it. We can take some of these questions live at the end. And then just for all the rest of the attendees, if we don't get to your question live today at our webinar, we will reach out to you via email after the event and make sure everyone gets all their questions answered. So again, thanks, Dan. We'll shift gears here and go to our next speaker, Jeff Scagnelli from Valmont Coatings, American Galvanizing over in New Jersey. Jeff, if you could share your screen. There you go. All right. Jeff, I'll just go ahead and hand it off to you for the second part of our webinar today.
Fantastic. Thank you. Quick check. Obviously, you can see my screen. Everybody can hear me okay?
Yep, sounded good, Jeff.
Fantastic. All right. Well, hello. My name is Jeff Scanelli, and I am the sales manager here at our New Jersey Valmont American Galvanizing plant. Today, I'm going to highlight the value your hot dip galvanizer can add when included in pre-project planning. So it's well established that hot dip galvanizing provides maintenance-free corrosion protection for decades, making it an excellent option for steel bridges. However, what's overlooked is the additional value and efficiency galvanizers can provide when involved early in the planning process. Your hot dip galvanizer is more than just a coater. We can be a technical partner. Involving your galvanizer on the front end can save time and money. A forecasting conversation can keep the project on track. A technical conversation can save dollars and cents. Many galvanizers offer pre- and post-galvanizing value-added services. We have a couple of them noted here. This is just a small sample of what some galvanizers may offer. On the pre-galvanizing side, we may be talking about the ability to burn and drill holes, absolutely offering design consultation, masking services, which we're going to kind of talk a little bit about in the upcoming slides. Incoming material inspection, which is really important for helping with project accuracy as it's running through the plant. Transportation, certainly important. Post-galvanizing, all sorts of things. It brings a smile on my face when I talk about burning and drilling holes. On the other side of that burning and drilling holes, there are options. We can plug those holes. There are suppliers that offer tapered plugs, and we can install them post galvanizing, which can really help the aesthetic of the project. Beyond that, we can offer fit up and assembly, QC documentation, transportation to the job site potentially, storage, sequencing. There's all sorts of value-added services. So, please keep that in mind when you're looking to reach out to your galvanizer. So today, we're going to talk about 2 case studies. I was fortunate enough to be directly involved in both of these. So the first one that we're going to talk about is the Pulaski Skyway, which is an 80-year-old highway that carries over 65,000 motor vehicles daily between Newark and Jersey City. This rehab project turned the Skyway from poor condition bridge into a structure with the extended life expectancy of 75 years. And if we look at the scope here, this was a 4 million pound project, 4 million pounds of steel to be galvanized. It was just a massive project, a multi-year project, over 200 floor girders. You can see that they were, almost 90 feet in length, 7 feet tall. So we're talking about some pretty big steel structures here. Some of the features we have listed at the bottom here, which we're going to talk about in the upcoming slides. The invitation to the design and pre-production meetings allowed Valmont to focus on key spec topics. Material dimensions were talked about, coating requirements, dimensional tolerances, project forecasting. These are all important things to think of, right? One of the first specifications to be discussed was the field installation of the studs to the top flange. And welding on galvanized surface is not advised due to zinc poisoning. So as a result, masking would be required. For those not familiar with masking, this is a term that we use to note a steel surface must remain bare or uncoated. And this is accomplished by applying a paste or a paint to the steel surface. The paint prohibits the pretreatment chemicals from properly pickling or cleaning the steel surface. When the steel hits the zinc bath, the paint burns off, leaving a bare, uncoated surface. So we know the authority wanted to maximize the galvanized coating, so we deviated from the typical full surface masking of the top flange, or even the masking strips of the top flange. And Valmont developed a template that allowed us to mask only the heat-affected areas of where the stud would be installed. And as a result, we maximized the coating area of the top flange and minimized material usage. So if you direct your eyes to this photo that we have here, you can see these beams were post-galvanizing, and what you're looking at, these circles, those were the masked areas. So when we take these beams over to finishing or dressing, that masking residue is going to be removed, and you're going to have just a bare spot there, and a nice clean area for that stud application. We also discussed material dimensions, and this was a large project. I noted over 200 floor beams. And we know that some galvanizers can successfully hot dip galvanized beams exceeding 90 feet in length. However, length alone doesn't determine whether a member can be processed. There's other factors, including beam depth, width, weight, lifting requirements, and kettle dimensions that must also be considered. So when girder dimensions exceed both the length and width of a galvanizing kettle, orientation limitations can restrict the amount of surface area that can be immersed in coating. In this project, several of the largest members exceeded our capacity for complete hot dip galvanizing coverage. So after discussions with the project authority, a hybrid corrosion protection system was approved, utilizing hot dip galvanizing to the maximum extent possible and metallizing to protect the remaining inaccessible surfaces. So your hot dip galvanizer can also provide valuable support beyond the galvanizing itself. While ASTM 123 certification is standard, some galvanizers offer additional quality control services that can save fabricators significant time and resources. On this project, we individually blocked each beam and girder to verify the camber, record the measurements, and provide the resulting documentation to both the customer and project authority. Although we maintain an open door policy and welcome fabricators to witness the galvanizing process, having a QC rep on site daily or weekly throughout a multi-year project is costly, right? So by providing detailed documentation, measurement records, and photographs after galvanizing, we help reduce the customer's inspection burden, lower labor costs, and strengthen the confidence in quality and consistency of the finished product. And you can see a couple of the site photos here, which are, really cool to kind of look at. And we also included what that camber measurement document might look like as well. The next project that I want to highlight is the RK-73 ramp structure, which is part of the RFK Bridge Complex. This is a critical piece of New York City infrastructure that carries tens of thousands of motorists each day. Given the importance of the structure, early collaboration between the owner, fabricator, and galvanizer was essential to ensuring the project met both schedule and performance requirements. Again, let's take a look at the scope here. 2 million pound galvanized steel project, very large, 120 bridge girders. They were 50 plus feet to almost 90 feet long. This was another very large project that required lots of discussion. Participation in the design and pre-production meetings allowed us to focus on key specification requirements before fabrication began. While masking was required on this project, the purpose extended beyond simply keeping the areas free of galvanizing. It was necessary to meet specific engineering and performance requirements. The project specification required a slip critical coefficient at the fang surfaces that a galvanized coating alone could not achieve. To address this, Valmont provided masking, surface preparation, and the application of a zinc-rich primer to the designated fang surfaces. By completing these services in-house, we eliminated additional handling, transportation, and labor for the fabricator, resulting in both time and cost savings. So, as the project discussions progressed, it became clear that there was an opportunity to provide additional value-added services. The fabricator was located in Maryland, right? My galvanizing facility is in New Jersey, and the project site is up in New York. So to streamline logistics and reduce handling, Valmont expanded its scope to include assembly of the connection plates prior to ship. So, again, you don't want to head north, back south, and then north again. So this was a great opportunity for us to talk about what else we can offer here at the plant, right? So we could take the connection plates, and fit them to the individual beams and girders. And we were able to do that. And we were able to even take it a step further and offer our ability to torque, to meet that tightening of those nuts and bolts to a specific torque specification. And ultimately, the customer decided to go with just a snug fit option and secure those connections with zip ties. But again, I say this to really highlight what the potential your galvanizer has. It's important conversations to have with them so that we can really understand what kind of value we can add to a particular project. At the end of the day, the Valmont played a meaningful role in providing efficiency and reducing overall project costs. We helped to get this project done a month ahead of schedule and saved just over $1 million. And I really do believe that the conversations that we had on the front end of both of these projects were crucial in helping keep the flow of the project, helping to keep the cranes moving at the site. There was very little downtime on either of these projects. Once they got here to the plant, we knew what was expected of us, and we were able to complete our part of the task and keep the project moving. One thing I will add here at the end, I think is really important when we talk about those pre-production meetings, is using the AGA, the galvanized.org web page as a website, as a source. I'm on it all the time. there's so many resources on there that help me create all sorts of different templates. You know, when I go and walk into a pre-planning meeting, there's publications on there for AESS projects, and the AGA offers some free production outlines and guidelines on there, and there's an updated bridge publication on there that can serve as the same resource. So please, I do suggest using their website. There's tons and tons of information on there. With that, I do thank you for letting me present these projects. They were a lot of fun. And yeah, again, thank you for your time.